Hello, my name is ASHIRA binti TAMAN, and today I will present about assignment presentation for our subject thermodynamic and heat transfer. For introduction is what is a heat sink. Heat sink is passive heat exchanger that transmit heat from an electrical or mechanical device to a fluid medium, typically air or a liquid coolant. Where did it use? They are most used in the computers, but also found in the cell phone, DVD players, and even refrigerators. What its purpose is to keep the component safe from overheating. How did it work? Heat sink work by using a thermal conductor to take heat away from a heat source, drawing it towards on its own large surface area that contact the cooling medium. According to this law, the rate of heat transfer through a material is proportional to the negative temperature gradient and array at right angle to the gradient. Fourier's law of conduction, Q as the local heat flux density, Ke is the conductivity or the thermal conductivity, At is for temperature difference between the endpoints and AX for the distance between two ends.
Okay, for design, we have two design, which is design 1 and design 2. First design is the length and the width is same, which is 40, and the height is 20 mm. So the thickness for each fin is 2 mm, and the height for each fin is 17 mm. So for design 2, also same, the length and width is 40 and 20. The thickness for each fin is 2 mm, and the height also is 70 mm. For the analysis, this is the result for design 1. For design 1, the maximum temperature, which is below here, the 323.31 Kelvin. When we convert to degree Celsius, we minus with 733, we got 50.31 degrees Celsius. For the minimum, which is the blue one, 323.24 Kelvin, and we convert to degrees Celsius, 50.24 degrees Celsius. For design 2, the maximum 335.02 Kelvin, and when we convert, we got 62.02 degrees Celsius. For the minimum, 334.85 Kelvin is 61.84 degrees Celsius.
Okay, so in the analysis for design 1 and design 2, design 1, the range of temperature when maximum temperature is minus the minimum temperature is 0.07. And then for design 2, the range of temperature when maximum temperature minus minimum temperature is 0.17. So based on the figure, the higher temperature distribution occurs in the bottom part of the heat sink, and further from the bottom part of the heat sink, the temperature gets lower. The heat source spreads slowly to another part of the heat sink. The maximum temperature of the heat sink is inversely proportional to the inlet wind. The higher the velocity of the air inlet causes the lower the maximum temperature of the heat sink. And we can see as the comparison from design 1 and design 2. And design 1 we use copper, and design 2 we use 1060 alloy. So as you all know, copper is better than alloy, but we just try and test which one is better. But for design 1, it's already using copper, but we design it You're using number of fins of 98. 98 of number of fins. And then for design 2, only 13 number of fins. As you can see from the design. And then the thickness of the fins in mm. For the first design is 5 mm and the second design is 2 mm. So for design 2, the thickness is quite low than the design 1, but the side wall is same because we don't have a side wall. We already using the fin or the fin sizes. And then the fin spacing, it means the spacing between fins to another fins. In the design 1, we get 0.8, and then for design 2, it's 1.0 mm. So for design 2, the spacing is quite bigger. And then for the effectiveness, design 1, we can see is lower than the design 2, and design 2 is higher. It is because the temperature difference we get as a maximum and minimum. And then the last one is thermal range in Kelvin. You can get it in Celsius by minus by 273. And then the maximum of design 1, 323.31. And the minimum is 323.24. It's range around 0.7. And then maximum 335.02. 334.85 minimum. And the shape is, for design 1 is teeth, and design 2 is single fin. As you can see from the design, that is a single fin. And then we further to the another slide.
Next, for the discussion, first, as we know, the process of heat conduction depends on temperature gradient, the cross-section area of the materials and properties of those materials. We can lower the temperature by increasing the length and surface area. Heat transfer from a surface is increasing by adding more fin. If fin have an extremely high thermal conductivity, then the surface temperature will be equal to that body. The greater the value of the convective heat transfer coefficient, the smaller fin's efficiency, as also happens with the fin's effectivity. Last but not least, the rate of heat transfer is inversely proportional to the thickness of the fin. The thicker that the insulation is, the lower the rate of heat transfer.
So for the conclusion, according to the design 1 and 2, we have analyzed that we choose the design 2 because of the range of the temperature. The temperature itself is lower and suitable depends on design 2. Therefore, the design 2 can be highly generic to the power supply because of the material. The material that we use is alloy. Besides that, the amount convection in the fin surface 1 is higher and it will causes the increase of the heat transfer. So that's all from us. Thank you.